Hi, this is how I created my Islamic geometry sketch in P5GS. At first, I set up the drawing environment. I defined the canvas, increased the pixel density for clean exports, as well as I set stroke join to miter and stroke cap to project, so the geometry has sharp architectural corners, and this established the visual precision of the system. Then, I turned the sketch into a parametric system. I added a morph slider to control the valley depth, a weight slider to control the strap thickness, and a checkbox to toggle the hidden grid. And the star is not going to be coded, rather it is a value radius that is mapped and constrained so that the form can transform continuously while staying structurally stable. I then introduce animation using an oscillator class. I increment time and pass it through a sine function, and this simple harmonic motion, it creates this animation that is periodic and also very smooth, and it becomes a temporal engine to the system. Afterwards, I constructed the octagon and the square using a vector math. Each vertex is calculated as a polar vector, and I define a magnitude and an angle, then resolve it with a cosine and sine. So even though I'm not using P5 vector explicitly, the entire geometry is vector-based. And I computed the octagon and the square apothems to ensure a proportional capability. And this is what allows the 884 tie lengths to align perfectly. I then built a garish strapwork system on the top of the polygon structure that I created. So basically there are two shapes in the system, a larger octagon tile and a smaller square tile. Each one has its own strapwork logic, but both follow the same principle. For each shape, I alternate between two radii. The first, the larger radius, and this is the midpoint radius. And for the octagon, this is the opothem of the octagon. And for the square, this is the opothem of the square. And then second, the smaller radius, this is the inward value radius, and this radius is mapped using the morph slider. So for every side of the shape, I place a vertex at the edge of the midpoint, the larger radius, and then place a vertex slightly inwards for the smaller radius. This alternating big and small, and then big, small again pattern creates the star geometry. Technically, every point is still constructed as a vector from the center, but magnitude equals radius and the direction equals angle. So basically by switching the two magnitudes while keeping angular spacing constant, the star forms emerges mathematically from the polygon. Then I render the strapwork in two passes. The first path, thick black stroke, and the second pass is thinner white stroke drawn directly on the top. Because strokes are centered on the same path, the white stroke cuts into the black stroke, and this creates the illusion of a woven like ribbon, if that makes sense. Lastly, I assembled this whole system together. First, I implemented the 8-8 grid using the parity logic. Then I applied the simple harmonic motion across the entire field. The offset introduces a phase shift based on distance from the center, creating a ripple effect. And the octagons add wave, squares subtract the wave, so the final system combines vector-based geometry construction, parametric transformation, simple harmonic motion, spatial phase displacement, and layered stroke rendering. So basically it's not a static pattern, it's a mathematically animated geometric field.